Hello guys, welcome to SSC JE Electrical CBT 2 2025. This is a practice series, so we'll practice as many questions as possible, and this is the day 2. Okay guys, so let's go to the first question. So here you can see the first question. A three-phase induction motor under DC dynamic braking. So DC dynamic braking has been used. It works as a dash. So whenever an induction motor is under dynamic braking, what happens is the three-phase supply to the induction motor has been cut off, and it has been fed with a DC supply. So these stator produces a steady and which is stationary magnetic field. So when the rotor here rotates in this magnetic field, what happens is as the speed of rotor is nr and the speed of stator magnetic field now has become 0, so nr is greater than ns. So an EMF is induced in the rotor. So these EMF, these currents will be fed to a resistance network if it is a slip ring induction motor. So that resistor will dissipate the heat, and eventually the motor will come to halt. So here how is it operating? It is working as an induction generator. So option C is the correct answer for the first question. Now let's move to the second question. A synchronous generator is operating with a leading power factor. If current increases, that is the field current increases, then armature current. So if you have want to find out the answer to this question, you have to know the inverted V characteristics. What is the inverted V characteristics? Inverted V curves. So this would be something like this. So inverted V curves is nothing but armature current was field current characteristics. Okay, so this is normal excitation at this point. Citation. So at this point the excitation is normal, so power factor is unity, or else you can say unity power factor. So under excitation it draws uh, more current, or over excitation it draws more current. So this is leading power factor and this is lagging power factor. So this is the characteristics of synchronous generator. So here what is happening? Field current increases, then the armature current. So if you take from this to 0 to IF, what happens is armature current decreases, it comes to a point, from here again it increases. So this is the minimum value, I minimum, that is armature current minimum. So which option is correct? Option C is correct, decreases to a minimum value and then increases. So option C is the correct answer. If you take for the motor, then these leading and these lagging will be interchanged. That's the only difference between the motor and generator. So let's go to the next slide. The rotor of synchronous machine has dash slip rings. So if you know the construction of a synchronous machine, you know that the stator doesn't have slip rings. Only the rotor does have the slip rings. Okay. So why does it have the slip rings? To produce a rotating magnetic field. So a DC supply is given to the rotor, DC supply. So positive, negative. So how many slip rings are there to provide the DC supply to the rotor? Only two, because positive and negative, only two polarities are needed. So the correct option is option B. Let's go to the next question. A three-phase synchronous machine with a synchronous reactance excess per phase and negligible resistance per phase delivers a purely leading current to a load. Its armature reaction has following effect. So what they are saying is a synchronous machine. So whenever they say a synchronous machine, most of the times it is a generator. Okay, assume it is a generator. So what they are saying, the synchronous reactance is much greater than the resistance, because the resistance is negligible, both are per phase values. So it is delivering a current which is leading. So what is the armature reaction? So whenever a generator is providing a leading current, it means that it has magnetizing effect. So whenever there is magnetization, it aids the magnetic field mmf, and it is called the magnetization effect of the armature reaction. So which of the options are correct? Option A means aids the mmf and it causes the magnetization effect. So that option A is the correct answer. So let's go to the next question. The speed torque characteristics of an induction motor are closely resembles the speed torque characteristics of A series motor, shunt motor, universal motor, synchronous motor. So whenever you take speed versus torque or you can say armature current, as the torque or the armature current increases, it will decrease. So most of the time in induction motor as well as the other motor, which is a DC shunt motor, the rotor speed almost equal to the rated speed nr. So and both are similar to each other. In case of series, it would be something like this, for example, like this, something series motor. Okay, so which is the correct answer? And synchronous motor nr is always equal to ns, so this is wrong. Universal motor, which is uh, series motor, but it can also work on DC as well. So those characteristics are like this also. So these characteristics are like this, and DC shunt motor, it is like this almost. So option B is the correct answer. The DC shunt motor and the induction motor speed torque characteristics are mostly similar. So option B is the correct answer. So let's move to the next question. An overexcited synchronous motor operating on no load condition is called as, what is it called as? Synchronous condenser. Okay, whenever a synchronous motor at no load is overexcited, what happens is it delivers reactive power to the grid, which means it is compensating the inductive load and improving power factor of the network. Improving power factor, compensating the inductive load, all are the same. So it is called a synchronous condenser. That is why it has capacitive characteristics. When two alternators are operating in proper synchronism, the terminal voltages are equal, synchronous power will be 0. Which statements are correct? So let's say this is a grid. Okay, so two synchronous alternators means synchronous generators, are operating in parallel. So what are the conditions for their parallel operation? One is terminal voltage should be same, frequency should be same, phase should be same, and phase sequence should be same. It means whenever all of these are same, they can be synchronized and connected to the similar grid. So what happens is when both are in synchronism, there will not be any circulating currents. So there is no synchronizing power. Whenever a torque or voltage in one uh, machine decreases, obviously there suddenly a torque will be developed to bring both in synchronism, which is called synchronizing power. So when both are in already in proper synchronism, the synchronizing power is equal to 0. So from this explanation we can assume that the terminal voltages are equal. So the statement 1 is correct. The synchronizing power will be 0. So statement 2 also correct, which means both 1 and 2 are correct. So option C is the correct answer. For maximum starting torque in an induction motor, so we know the condition for maximum torque. For maximum torque, R2 is equal to Sx2 is the condition. So it is a starting torque. At starting, we know that at starting the slip is equal to 0. Sorry, slip equal to 1 because Ns minus Nr. Nr rotor is not rotating at start, which means Nr equal to 0, Ns minus 0 by Ns equal to 1. So slip equal to 1, which means that R2 equal to slip x2. When we substitute S in this equation, we get R2 equal to Sx2. So which is the correct answer? Option B is the correct answer for this question. Let's go to the next question. In a synchronous generator, the voltage regulation is always positive in case of. So we know that voltage regulation in synchronous generator, it is positive in both the cases, that is unity power factor and lagging power factor, and it can be positive, 0 and negative in the case of leading power factor. So it is always positive in both unity power factor and lagging load. So option D is the correct answer. The most common application of induction generator is steam power plant? No. Here synchronous generators are used, that too non-salient poles type is used. In hydropower plant? No. Synchronous generator, salient poles are used because this is high speed, this is low speed. Wind power plant is the correct answer. Here we used induction generators. So option C is the correct answer. And nuclear power plant is again steam, so again synchronous generators. So option C is the correct answer. Induction generator is used in wind power plants. let's go to the next question. The shaded pole induction motor is used in. So we know that shaded pole induction motor has low efficiency, low starting torque. So it will be used for only low power application like fractional watt motors, like toys, photocopy machines, advertising displays. So what is the correct answer? All of the above, which means option D is the correct answer. So next question, to damp out the oscillations and to develop the starting torque in synchronous motor, which technique is utilized? So obviously it is damper winding. So what is a damper winding? So synchronous motor there is a rotor. In the rotor it has DC field winding. Okay, so along with DC field winding in the you know so let me draw this again. Pointer option, erase. So you can see, for example, this is a rotor of synchronous motor. So here there is a winding. So this is north pole, this is south pole. So winding will be there with along with slip rings. So what happens is, to give it a proper starting torque, bars are placed in the pole face. Okay, these bars are short circuited with a end ring. So what happens is, it acts as a squirrel cage rotor at starting. So an EMF will be induced, it will cause eddy currents to flow, and it will produce a starting torque. Okay, and whenever there is a oscillations, like whenever there is a sudden loads, what happens is the motor starts to oscillate, the rotor starts to oscillate, and it may fall out of synchronism. So for that, whenever there is a hunting, again the NR is not equal to NS. So again eddy currents will be induced in the squirrel cage rotor bars, and it will produce a torque, and again it will come into synchronism. So these bars which are placed in the rotor poles are called damper windings. So they help both in hunting, preventing hunting, and providing starting torque. So option A is the correct answer. So let's go to the next question. What is the frequency of rotor current of a 50 Hz induction motor operating at 2% slip? So we know that the rotor frequency is equal to slip times of supply frequency. So what is the slip? 2%. So 2 by 100 into 50. So 0.5 into 2 is equal to 1 Hertz. So what is the correct answer? Option A is the correct answer for this question. Next question. The motor used in ceiling fans. We all know the motor in ceiling fans is single phase induction motor, which has two windings. One is starting winding, which has high resistance and more number of turns, and the running winding, which is thick and less number of turns, which has this has high resistance, this has high reactance. Okay, and the rotor is like a squirrel cage rotor. So it is a split phase, but it is capacitor, it will be there. So it is a capacitor start motor. What will it do is, it will provide a phase displacement of 90 degrees, not exactly 90, near to 90 degrees between the two currents. So this is I auxiliary, this is I main winding. So this will provide the phase displacement between the two and provide the rotating magnetic field. So capacitor start motor is the correct answer. So next question. The cogging of an induction motor can be avoided by. So what is cogging? What is cogging? Okay. So for example, you say there is a north pole which is there in the stator, and there is a south pole in rotor. For example, this is stator side and this is rotor side. So what happens is they, sorry, from north to south, so they will interlock. So due to this interlocking, what happens is uh, the torque will be zero, because obviously it is an induction motor. As the rotor speed becomes equal to the synchronous speed, it will give problem. So how to avoid this cogging in an induction motor? So proper ventilation, no. Using a DOL starter, no. Auto transformer starter, no. So by making, having number of rotor slots more or less than the stator slots. So this is the correct answer, option D. So when the rotor slots are equal to stator slots, there will be interlocking. If it is not equal, then there is no positive probability of interlocking. And other thing you can use is that skewed rotor bars. By this method will also prevent the cogging in the induction motor. So two methods. One is the making the rotor slots which are not equal to stator slot, or using skewed rotor bars. So let's go to the next question. A three-phase slip ring induction motor having negligible stator impedance drives a constant torque. If an additional resistance is included in the rotor circuit, what does the motor experience? So we all know that torque in an induction motor is equal to 3 into 60 by 2 pi ns, that is synchronous speed, into s e2 square r2 by r2 square plus sx2 whole square. Okay. So negligible state drives a constant torque load if an additional resistance. So you can say that torque is directly proportional to slip and inversely proportional to R. So what is given? Constant torque load. So when torque is constant, so what happens here is R becomes proportional to slip. So whenever resistance in the rotor is increased, the slip will also increase. And as the rotor resistance has increased, the equivalent resistance of the circuit, resistance also increases, which means the current decreases. Okay, so slip increases and current decreases, so which means increase in stator current and no change in slip. No, this is the wrong one. No change in stator current and increase in slip, B also wrong. Increase in both stator current and slip, wrong. Decrease in stator current and increase in the slip. So option D is the correct answer. Let's go to the next question. Which of the following is not an application of synchronous motor? So power factor improvement, we use synchronous motor for obviously power factor improvement. And in a synchronous motor, nr equal to ns means it will always work at constant speed. So it is a constant, it can be used for a constant speed drive. So variable speed drive is a correct answer, because a synchronous motor cannot be used for a variable speed. So option A is the correct answer. Next question. In AC machine, the coil in which EMF is induced due to main field flux is known as. Let's say for example we take a stator, a synchronous generator. Okay. So the main field is on the rotor. So whenever it is rotating, EMF induced in the stator winding, right? So it can also be called as armature winding. So field winding is not the answer, dummy coils is not the answer, none of is not the answer. Armature winding. So EMF is induced in the armature winding, that is stator. So option B is the correct answer. Zero power factor characteristics is plotted between. So ZPF characteristics are plotted between V versus IF. V and inverted V curves are plotted between IA versus IF, and inverted V curves are plotted between power factor cos pi versus IF. These things you have to remember. So ZPF is terminal voltage versus field current. So option B is the correct answer. In a three-phase induction motor, for low value of slip, the torque is. So we know the torque is equal to K SE2 square by R2 square plus SX2 whole square. You have to remember this formula. So for low values of slip, the torque is proportional to. So you can say, as it is low values of slip, this will become negligible, and the R2 is constant, so this K is constant, E2 will be a variable. So what is there? T is directly proportional to, torque is directly proportional to slip. You can also see slip equal to 0, slip equal to 1, torque. It would be something like this characteristics. So this is the maximum torque or pull out torque. So in this region, for the low values of slip, torque is proportional to S, slip. So correct option is directly proportional to the slip. So option B is the correct answer. So let's go to the next question. So that's it, guys. That's it for today. Please like and subscribe to my channel if you don't want to miss the upcoming videos. Thank you for watching.